Okay, hello for the last time today in Kino Nowe Horyzonty on the 9th Nokia Code Dive edition. Please mute your phones because we will have our last presentation and we don't want any interruptions. And our last but not least speaker is Marta Rogowska. Marta has been an employee in Nokia for last 5 years, but she's also experienced in academic research. In her presentation, she will be able not only to discuss the research grant implemented at Nokia, but also she will be able to compare applying for fundings in the company at the university. Marta Rogowska, good luck.
Thanks for the introduction. So thank you for coming to my presentation. The title is Innovative Solution in the 5G Standalone Network. It's quite general, I think, but it is related to the research project that we develop in 5G team. It was said a moment ago that I've been working at Nokia since 2017, and during this time I had a pleasure to participating in creation of a grant proposal for 5G standalone network research project. And this application was accepted by National Center for Research and Development. It was some time ago, so today I can present to you the final result of this project and also all difficulties we encountered during this work, all works and something like that. So we can move to the next slide. So today I will focus on 3 major aspects. First of all, I will describe our project, our goals, assumptions, and something like that. I will tell you who developed this project, where it was, and something like that. After that, I will say a few things about innovations in this project, in our work, and after that, I will present results. But I think that's not all, because before working at Nokia, I gained some, let's say, scientific experience at Wroclaw University of Science and Technology, and now I think I can present to you the difference between between work based on research project at the company and at the academy, and it may be interesting to you also. So let's start from the first item of the agenda. A few words about the research project. So at the beginning, we create a small team, which called R&D key personnel. It was me, another one specifier from the 5G team, one 3GPP delegate from our company, and also one line manager, which was project manager in this proposal. So I think that here we have the first difference between the academy and the company, because in the company we hired people to writing a proposal. At the academy it's not possible. So, but I think that it sounds better when it is actually, because we still, of course, we got from the company Ernst & Young a lot of tips to writing a proposal, a lot of advice, a lot of advice to what we should avoid in our proposal and something like that. But still we had to come up with the goals, the assumption of our project. We still have to provide technical content for the application, and at the end we still had to correct the draft of the application. So it's not a big difference, like it seems. Yeah. Oh, sorry. It's a tricky thing. Okay, so after creating a proposal, we got the acceptance from the National Center for Research and Development, and we received funds for the work. But how you can see here, we need a lot of engineers to implementing our goals, our assumption, and it was more than 200 engineers in different specialization. Most of them it was developers, but also specifiers and testers. And here you can see the official title of our project. I know it's long and really complicated, but it has some reason, because it increases our chance to get the foundation. So it's official one, but our daily title for the project is like the title of my presentation. And here you can see also the dates. The first dates refers to the implementation process where the engineers were working on our feature, our implementation, and after that we have the implementation of the project results. And now we are at this stage. So today I have the opportunity, but also I have to present our results in the conference, for example, on other events. Yeah, I think that's all here. So the main goals of this project are, I think that you can know these goals, because it refers to the 5G technology. And the first one was that the final effect will be to check the effectiveness of the 5G standalone system, but in less popular bands. We plan that it will be for 400 megahertz frequencies and also 28 gigahertz. The second one is to minimize delays in the data transmission, and we would like to achieve about 1 millisecond. And the third is greater reliability, because we plan to implement the functionality of high availability for our 5G standalone system. And also the last one, it is the functionality which is quite new in 5G technology. It's new state, RRC inactive. So it was the last point for our assumption. And yeah, the issue is to be developed under the project include the following things, because we need to do some industrial research in the field, and also we work not only in software area but also in hardware area. I didn't mention it earlier, but we have small cooperation with 5G small cells team from the Krakow in Nokia, and we also prepare control layer for connection handling, especially in 5G standalone as a software, and also develop the other functionalities which was necessary to achieve our goals. As I mentioned before, we have one 3GPP delegate, and we it was a good thing for us because we can actively participate in 3GPP meetings, and despite the slowdown caused by COVID pandemic, we achieve our goals, and we attended on, I think, nine meetings, 3GPP meetings, and we could include our work there. It refers to improving mobility for new radio assay. It was related to the handover functionality and something like that. But before saying a few things about innovation in our project, I would like to briefly introduce the overview of 5G standalone and non-standalone network. As you probably know, if we talk about the next generation of telecommunication networks, it is developed in an iterative manner. So in next generation, we have new functionality, new features for these mobile networks. So for the 5G, we have unlimited data capacity, but we start from the analog communication. So it's a quite big history for that. Here you can see the requirements and use case for the 5G standalone technology. And you can see here that our goals are similar to these requirements and this use case. We didn't discover these things. We only analyzed how we should implement this in our system. So it was our innovation, our work, not the discovery of these features, but how we should implement it in our system, 5G system. I also put here some general overview of our architecture, because we talk about standalone network, 5G standalone. So it's only based on the 5G infrastructure. So we have only 5G core. We have a G-Node B, 5G Node B, which is some logistic representation of the base station. And we have also typical for 5G interfaces like XN, F1, NG, and something like that. You can also here see the mapping, some kind of mapping between the physical part of the system and logical parts like G-Node B. G-Node B is divided into two parts, DU and CU. And G-Node BCU is mapping to radio admission control protocol, and DU is more related to the physical entity like radio unit or radio access unit. This approach brought us some benefits. So it was supporting network scaling, improving the flexibility of the network architecture, and also, of course, cost reduction. And it is a really important benefit for us. Also, we have simplification of the core network, ensuring easy network segmentation. It is related to the network slicing functionality, but this functionality wasn't included in our research project because we only could include this functionality, which was completely developed and implemented in Wrocław. We couldn't use any features that was our implemented on China or something like that, because our funds came from the Polish Center for the Research and Development. So it was a tricky thing in this case. So now the operators can choose, of course, in what deployments they're introducing 5G. They can choose 5G standalone, as I said, with all functions and features of for this technology, and completely related on the 5G infrastructure, or can choose also 5G non-standalone, where we have some, let's say, transition model based on the 4G network infrastructure. So here you can see some comparison between these deployment options. We have 3 options here for 4G, so LTE technology, and for a mixed option for non-standalone 5G, and for SA, so standalone option of 5G network. Okay, I think the first quite big functionality which we should implement in our team in this project was connection handling. So we concerned on totally basic functionality for connection handling, and it was connection to the base station, from the base station to the network, connection between client device and the base station, and also handling of the client connection. So all these functionalities were implemented in our team with success. It's also required from us the features related to the new 5G interfaces, like NG-XN or E1, and establishment of these interfaces. Also we need to implement self-setup procedures. So it was a lot of work for our engineers, but we had for this work 2 years. So quite big, quite long time. Okay, so as part of handling of the client connection, the features related to the radio admission control and PDU session setup functionalities also were required and were implemented in our team. But as probably you know, all features related to the 5G based on 3GPP specification, but and most of them are similar to 4G, I think, for LTE. But we have some quite totally new functionality, like totally new state in 5G technology. RRC inactive. I think that it's the biggest difference between LTE and 5G networks, that we have new RRC state. So this new state was provided to reduce cost. I think that not only energy cost, but also it reduced signaling load and something like that. So it was important to us to keep this feature in our team and implement it. Yeah, maybe to some of the benefits we have, of course, reducing energy consumption in our mobiles. We can optimizing the use of radio resources, and also we can in efficient way use machine-to-machine systems and of course, in consequence, IoT systems. The second quite big functionality was high availability. And what does it mean exactly? It means that in the case of component failure, the mechanism that monitors the components totally transparently to our user will switch to the connection to the spare component. So in order to maintain data continuity, we also, when we're switching between the components, we store our data in SDL, shared data layer. So it's also our product. And this feature increases, of course, the stability of the internet connection in our 5G system. Oh, sorry. Yeah. I think that later I will show you the exact results of this implementation. Like I said at the beginning, we also working on hardware part. We have some hardware systems in our TC in Wrocław, but also in the Krakow. So for this specific research project, we use a UE simulator. We use some system modules like AirScale airframe and also airframe switch and radio modules. Here in Wrocław, we had 2 test lines for entity testing for clouds. We also have 4 test lines dedicated to basic call for our project also. Here you can see the UE simulator on the left side. It's COPHAM. So it is connected to the outgoing signal from the radio. And also on the right side, you can see the radio module configuration of this module allows us to test end-to-end our solution in end-to-end way with this UE simulator. And still, all of this hardware is in our TC in Wrocław. Here we can see also IMF simulator on airframe here, and our DU on AirScale system module. And like I said, we have also some baseband modules from Krakow, and also here you can see radio spectrum signal analyzer. After implementation of our features and after testing of this technology, we can sum up some project results in our team. So thanks to our research and provided technical solution in software and also hardware, we achieved some record in November 2020. The measured data transfer rate between the base station and the 5G phone was 8 gigabits per second. So when it was recorded. Later I have some press report on this topic, so I have some evidence that it happens. So the second result is reduction of transmission delays. So we achieve it thanks to the significant minimization of delays in our 5G mobile networks, because we use a solution in application and system requiring real-time response, and it is possible. This will allow us to the rapid and dynamic development of such industries, autonomous transport and logistics. It's quite a general result, but here the more interesting is that we we can use new radio bands. It was 38 gigahertz, not 28, like I said at the beginning, in our mobile 5G system. So it was our goal, and it's quite good that we can achieve it. And also, the last two results are related to our new innovative features, high availability, and also RSI in active state. So for high availability, we in our 5G team, we implemented we duplicate 4 components of the C-plane software. It was for CP cell, CPUE, CPIF, and CPNB. So it allows us to significant reduction of the connection failure rate. So it's a big success, I think. And also we implemented the state change mechanism. For example, to change the state from the RRC idle to connected, or connected to idle, and also from connected to inactive state and from the inactive to idle. So it was, these functionalities were implemented also during this time where our project was conducted. So yes, here we have some evidence from press reports. But I think that you can also see that it's Nokia reports. But here we have some values that in Turkey we achieved 4.5 gigabits per second 5G speed. So it was quite good results, but the record was 8 gigabits per second in Finland in 2020. Yeah. Oh, and that's all. Thank you for your attention. If you have any question, please ask. I will try to explain. And I think that I would like to encourage you to maybe when you work at Nokia or other telecommunication company, that you may think in other way, that we also can do some research, some study in our firma, not in our company, not only our daily work with a small part of software, where I think that in many cases developers don't even know what exactly implement in the general overview. But we have a lot of opportunities and also research grants. It wasn't only one research grant in our team. We have also grant for IoT systems, so it's quite a popular way to receiving funds for Nokia. Thanks.
Do you have any questions? Please raise your hand if yes. If no, okay. Thank you, Marta.
Thanks.
Thank you once again.